Hello everyone, my name is Jacob Franklin.
And I'm Alex Escobar, and we made the Walking Buddy. Our overview of the project is basically we made the Walking Buddy to assist with blind people to cross roads or to cross anywhere basically safely and soundly. We sent the car back and forth across crosswalks, and we kind of just wanted to see how it could help blind people or somebody of deaf or somebody of that nature that is incapable of crossing the road by themselves. Now, we made speakers and we put a lot of LED lights on it so that way it's somewhat seeable, but also you can hear it. So if you're deaf and blind, then you're kind of out of luck. But the good part is the Walking Buddy will be there to assist you and help you.
The motivation of the project, my sister's actually a deaf interpreter, and deaf isn't blind, but that's kind of where the motivation comes. How can we help people who are less fortunate than me and you? So we figured one day we were driving down the street and we heard a crosswalker beeping, and we said, well, what if there's a more efficient way to help these people cross the streets? And then that's where the motivation came from. We kind of said, well, we have to make a project. Why don't we make our car help these people cross the street or do travel from place to place safely?
This is our equipment list. Pretty much we used everything that we learned in the previous labs. The LED lights, the breadboards, the resistors, the Arduino boards, everything that we used in the past.
The schematic and circuit design, most of it's just the base circuits that we were given before. As far as, the setup of the car, we did have to add, of course, the LEDs, which we used from, things like even in the lab exam, they had examples of this, previous labs from Tinkercad and things like that. That's kind of how we figured out the circuits. And then also it was a lot of just, testing and seeing what worked and what didn't work.
Okay, so like my partner said, it was a lot of testing and trial and error type, precautions that we took. But here's our code and flow chart. We started off with the sensor turning 90 degrees and try to see which way they could take us. We figured is it the distance between the ultrasonic sensor or the closest object to the actual car? And then we kind of just asked our questions to get ourselves to how the LED lights would light up or how it would all work when crossing the road.
So some of the major problems we ran into was the original obstacle avoidance code we had from the previous lab wouldn't work. We used the same code, and for some reason, it literally just kept going backwards. And that was a big problem, as that was the majority of our project was, all right, we have to get this base code to work in order for us to move on. So that was a big problem. Another big problem was, of course, having to figure out how we're going to work with one of us in the state and one of us without being in the state. As well, some of the LED lights weren't working, like we said, with trial and error. That's how we kind of figured that out. And then as well, with the original design of the car, there wasn't a lot of pins available for us to use. So we had to figure out how we were going to fill these empty or these LEDs and the speakers with lack of pins.
And like my partner just said about all of our problems, we found solutions to these problems. We've copied the code from one sketch to another, and it worked just fine. Me and my partner Jacob here, we got on Zoom calls or FaceTime calls. We talked pretty much every day. So everything worked out. We replaced the LED lights with wires, and we moved things back and forth. And really, the project just came together in the end, and we got everything figured out, and it works perfectly fine.
Here's a short little video of the robot actually working. We decided not to go across the street because that would cause some danger that we didn't really need. As you can see, you could probably hear too, the robot makes different noises depending on which way it turns. And then, of course, it stops distance-wise when it gets close. We did a area similar to that of a crosswalk. And then here, you can see the robot in action. So the green light's going once, going forward. When it stops, the red LED is solid. No noise being made. Turns left, so the green light blinks twice. Goes forward again, the green light goes again. Stops, and then the red LED blinks, or the red LED is solid. And then when it turns right, the red LED is going to blink twice and it's going to beep.